So in this video we're going to look at a couple of examples where you need to use trigonometry to solve problems, and example 18 is the sort of thing you're likely to get not only in this exercise but also in a GCSE paper. It may not literally sort of stick a triangle in front of you and say find x. It may well be a worded question. In fact, it's probably more likely that in the new GCSE this is the sort of thing you're going to get. So it says a window cleaner has a ladder that is 7 meters long. The window cleaner leans it against the wall so that the foot of the ladder is 3 meters from the wall. What angle does the ladder make with the wall? So really the skill here, the maths is pretty straightforward as long as we're all right with trigonometry and Pythagoras and so forth. The trick here is actually being able to get the words into a diagram. And whenever you are doing a problem where you're given no diagram, if it's trigonometry or anything sort of shape and space or geometrical, anything like that, the first thing is you've got to draw a diagram. So it says the window cleaner leans it against the wall. So I need a wall and we probably need a floor, because whenever there's a wall there tends to be a floor somewhere fairly near. And it says the ladder is 7 meters long. So let's just get a 7 meter long ladder that will have a blue ladder. So there is our ladder leaning against our red wall and red floor. Now, as we can see, we've got a right angle here and we've got some measurements. It says the ladder is 7 meters long. Well, the ladder is the blue line, so that means that is 7 meters. And it says the foot of the ladder is 3 meters from the wall, so that's this side of the triangle is the 3 meters from the wall. What angle does the ladder make with the wall? Well, the ladder, this is the angle that it makes with the floor. The angle it makes with the wall must be this one. Okay, so we'll call that one theta. And now it's exactly what we've been doing, trigonometry. So we'll start with identifying which sides we've got. Well, that's the opposite side. This is the hypotenuse. So we're dealing with sine. So sine theta equals O over H. Sine theta equals 3 over 7. Theta equals sine to the minus 1 of 3/7. Then it's time for our calculator. Second function, sine. 3 divided by 7. And we get 25.4 degrees. And that's to 1 decimal place. Okay, so that's all we would do. And the trick is all about getting the diagram drawn correctly. Once the diagram is drawn, it's a relatively simple process. The maths is what you've been doing. It's about making sure you put the right values in the right place, and actually that sort of initial trying to work out what the diagram looks like in 2 dimensions or whatever it may be. Anyway, there's example 18. And then another typical type of problem in trigonometry is the idea of angles of depression or elevation. And this gives us an example of what these are and what they mean. So from the top of a vertical cliff 100 meters high, Andrew sees a boat out at sea. The angle of depression from Andrew to the boat is 42 degrees. How far from the base of the cliff is the boat? Right, so from the top of a vertical cliff 100 meters high. So first of all, probably shouldn't do that bit in blue. Let's do our cliff in black. There's our cliff and it's 100 meters high. So there's that bit. Then what have we got? Andrew sees a boat out to sea. The angle of depression from Andrew to the boat is 42 degrees. So Andrew's looking, oh, that's not a straight enough line. Let's get a nice straight line. Andrew is looking down at a boat that's on the water, and we'll have blue for our water. And we've got some measurements here as well, haven't we? We've got the 100 metres. It says the angle of depression from Andrew to the boat. The angle of depression means the angle he looks down through in order to be able to see the boat. So actually we kind of need another line here. We need another vertical line across there, because the angle of depression is here, and it says that's 42 degrees. Okay, now we've got different options here. One is that actually we, instead of doing what I started doing and drawing the C in, we just have put an extra line in over here, and then we use this as our right angled triangle. We've got 42, we know that's 100. So what we're trying to find, it says how far from the base of the cliff is the boat. Well, here's the base of the cliff, here's our boat. So we're trying to find this distance here, which I'll call X. But similarly, we have now in our scenario in the other triangle that we've drawn, which has made it a rectangle, this must be X as well. So we could use this triangle. Actually, I'm going to go right back. I'm going to say that once I've got my angle of depression in, this is what I would do. So we drew in our angle of depression, and actually because of that, this line here and this line being parallel, this must be 42 degrees as well. So I'm going to call this X, and we're going to use this triangle at the bottom with our nice blue line. So what have we got? We've got opposite and adjacent, so that's tan. So tan theta is O over H. So tan 42 is 100 over X. So X tan 42 equals 100. X equals 100 over tan 42, which we then can work out on our calculator. 100 over tan 42 is 111.1 distance, so it's 111.1 meters. Okay, so an angle of depression is the angle you sort of turn through to look down at something, whereas the angle of elevation would be, and we'll just do a quick example of this, an angle of elevation would be, for example, when somebody is stood at a point on the floor, let's say here, and there's an aeroplane in the sky, and that's up here. So this is A, where the person's standing, B is an aeroplane, and the angle of elevation when Barry looks at the aeroplane is 40 degrees, for example. Okay, if he knows that it's 3 kilometers from where he's standing to vertically below the aeroplane, how high is the aeroplane? Okay, so that's the sort of thing. And there's a little problem you can work out if you wish. I'll just pause for a second, let you pause the video, and then you can just check and see whether or not you got the right answer. Okay, so solving this, we've got tan 40 equals x over 3, as it's opposite over adjacent. So 3 tan 40 equals x, and that is 3 tan 40, 2.517 kilometers. So it's 2,517 meters in the air. So that should get you through the next section, work through any problems, issues. Remember, diagrams are really important. If there is no diagram, you must draw one. If there is a diagram, you probably should draw one just so that you can mark on different lengths and bits and pieces as you work them out. So good luck. Any questions, let me know.